In lesson 7, we're going to look at how to divide polynomials. So in this first example here, we want to divide the polynomial on top, 10x to the 5th minus 15x to the 4th plus 20x to the 3rd. We need to divide that all by 5x squared. So what that really means is I need to divide each of those pieces of the polynomial in the numerator by the denominator of 5x squared. So I actually have 3 things that I need to look at. So I'm going to split this up as 10x to the 5th divided by 5x squared minus, so then I'm going to do the second term in the polynomial, so minus 15x to the 4th divided by 5x squared plus 20x to the 3rd divided by 5x squared. So essentially I'm dividing each individual monomial by the 5x squared. So you have to make sure, that's the number one mistake, is that some students will only divide by what's convenient, and you have to make sure though, even if it's not necessarily the easiest thing, is that when you want to simplify this, you have to make sure that you divide every single piece here by the 5x squared. So otherwise we wouldn't be able to do any kind of reducing. We would just have to leave it as is. So let's look at how I would now divide each individual part. So the first thing here is divide the numbers. So 10 divided by 5 is going to be 2. Keep the base, and then you just subtract your exponent. So 5 minus 2 is going to give me 3. Then I go to the next term. 15 divided by 5 is 3. Keep the base, subtract the exponent, so we get 2. Then I have addition. 20 divided by 5 is 4. Keep the base, subtract the exponent, so it's just going to be x to the 1, which I'm just going to leave it as x. So that's it. So that's reduced. Let's look at another one. So for this one, now I'm going to have 4 individual pieces because I have 4 terms up top in this polynomial. So I'm going to rewrite each of these pieces divided by 4a squared b squared. So I'm just rewriting these so that I remember to actually divide every single piece by that 4a squared b squared. And then once I have these all done, then I can go through and individually divide each piece. So now I look at 10 over 4. So 10 divided by 4 doesn't come out to a whole number, so we're just going to leave it as a fraction, which means I'm going to reduce it. So a number that goes into both 10 and 4 would be 2. So when I divide this by 2, I get 5. When I divide this by 2, I get 2. So this is going to reduce to 5 over 2. Then I'm going to keep my base of a, and I'm going to subtract the exponents, so the 4 and the 2. So 4 minus 2 gives me 2. Then I'm going to do the next piece here, which is b squared divided by b squared, which is the same thing, so they really just cancel each other out and become 1. So b squared divided by b squared is just 1. And then I move on to the next term. 8 over 4 reduces to 2. Now I have a 1 up here, a to the first divided by a to the second. So you keep the base. When you subtract, 1 minus 2 is going to give me a negative 1. And then my b's are just going to be b to the first, because it's b to the third minus b, or divided by b to the second, which means to subtract your exponents. Then we go to the next term. 12 divided by 4 is 3. And we have just an a left because we do 3 minus 2. And then again, now I have a b to the first over b to the second. So when you subtract your exponents, you're going to get a b to the negative 1. And then the last piece, 6 divided by 4 doesn't come out to a whole number, so we're going to look at how do we reduce this. So divide the top and bottom both by 2. That's the biggest number that goes into both 6 and 4. And we'd be left with 3 over 2. And then again, we have a to the first, b to the first, and we are dividing that by a squared times b squared. So we're going to be left with an a to the negative 1 and b to the negative 1, because I'm doing 1 minus 2, which gives me negative 1, and 1 minus 2, which gives me negative 1 for the b exponent. And then the last thing that we can do here, I could say I'm done and leave it like that, but anytime we have a negative exponent, we can rewrite it so that that exponent becomes a exponent down in the denominator. So I'm going to leave this as 5 over 2a squared for this first piece. Then it's going to be plus 2b, and it's going to all be over a because a was raised to the negative 1. So I make the exponent positive and put it in the denominator. So this is really like a positive one as the exponent. The next term will then be 3a over b. And then here I'm going to actually just have 3 on top. And then down on the bottom with 2, I'm going to have a and b because those both have an exponent of negative 1. So that's it for that. And then let's look at some other examples. So in the next situation here, we have long division of polynomials, which means what happens if we had some examples. So in these examples, we were able to divide everything by 5x squared. In this example here, you were able to divide everything by 4 times a squared plus, or divided by 4a squared times b squared. But what happens if you have something that looks like this, where you want to divide this entire polynomial by x minus 5? And if you look, you can't take out an x minus 5 out of each of these terms. So we can use long division, or you could factor if it's a factorable expression. So when we did factoring, we always looked at breaking the expression into its factors, and then we could pull out a factor, like an x minus 5, something like that. But in this case, this is a cubic polynomial, and it's much easier to learn how to do long division than it is to have to worry about factoring and maybe finding out that it's not even factorable. So let's go ahead, and before we talk about long division of polynomials, let's refresh your memory on how we do long division of whole numbers. So for example, if I have 2,837 and I want to divide that by 15, you first look at 15 going into the first number, which it doesn't. 15 does not go into 2. So then I look at it as 15 going into 28. It's going to go into 28 one time. So then I'm going to multiply 1 times 15. And then you're going to subtract it. So we're going to be left with a 13. Then you always carry down the next term. So now you're looking at how many times does 15 go into 133, which is going to be 8. And sometimes you might have to guess and check. You might find out that there's a bigger number, but in this case, it works out 8 times. So then I'm going to do 8 times 15, which is going to be 120. So then we subtract. We have 3 and 1. Bring down the 7. And you ask yourself, how many times does 15 go into 137? The answer is 9. 9 times 15 is going to give me 135. And that means I'm left with a remainder of 2. So your answer to this would be 189, remainder 2, which really means, since it's a remainder of 2 and we couldn't do 15 into 2,837, we write our final answer as remainder 2, which really means we have 2 out of 15 left, because we couldn't form another 15 group to put into the 2,837. So this would be your answer. You just add on that remainder over whatever you divided by. So let's look at an example with polynomials. So let me get rid of this piece here. So we have this example where we want to take this entire polynomial, we want to divide it by x minus 5. So I'm going to start it off the same way. So x to the third minus 10x squared plus 20x plus 26. We're going to divide that by x minus 5. So since I have 2 terms here, I have to look at these first two terms and what I'm in my polynomial. So the easiest thing though when you're looking at this is to only compare the first terms. So if I want to compare x going into x to the third, I have to ask myself how many times or what do I have to multiply x by to get x to the third? And the answer is x squared. So x squared is actually going to come up over the second term here because we're dividing by two terms. So it's going to be x to the second. And then we're going to figure out when we multiply, we just have to make sure that we multiply x squared by each of these x minus 5 terms. So I'm not going to worry about this 5 going into anything yet. That'll kind of just take care of itself. I'm always just going to look at the first terms. So x squared times x is going to give me x to the third. And then x squared times minus 5 is going to give me negative 5x squared. So I basically am using this minus 5 just to distribute when I picked that term up top there, the x squared. So then I'm going to subtract, and these are going to cancel. So then I have minus 10x squared minus negative 5x squared. Now, notice that I put parentheses because I'm subtracting off this entire expression, which means it's really going to be negative 10x squared plus 5x squared because I had a negative times a negative. So it's actually going to end up being a negative 5 because it's negative 10 plus 5, and then I just keep the x squared. And then just like the other problems, you bring down the next term. And now I'm comparing again just these first terms. So I'm looking at the first terms. How do I get x to become negative 5x squared? Well, I would multiply it by negative 5x. So then I just have to distribute this negative 5x through to each piece over here. So I have negative 5x times x is going to be negative 5x squared. And then I have negative 5x times negative 5 is going to be plus 25. And then again, you're subtracting these, but you're subtracting off the entire thing. So these cancel because it's a negative plus a 5, negative 5 plus 5. Here it's going to be positive 20 minus 25, which is really going to be a negative 5x. And then I carry down my last term, so plus 26. Then I go and compare the negative 5x with this x, and I ask myself, how do I get x? What do I multiply x by to get negative 5x? And the answer is negative 5. So up top here, I'm going to write minus 5. And then I distribute that minus 5 through. So minus 5 times x is going to be negative 5x. Negative 5 times negative 5 is going to be plus 25. And again, you're really subtracting off this entire thing. So these first terms always should cancel. That's how you know you found the correct number. And then 26 minus 25 is going to be 1. So that means I have a remainder of 1 because I don't have any other terms to carry down. So my answer is going to be, so let's write this out. So the answer to this is going to be x squared minus 5x minus 5 plus your remainder, which was 1 over whatever you divided by, because you didn't have another x minus 5, so you were left with 1 over x minus 5. So that's it, but let's look at a couple more examples so that you become familiar with it. So on this page, we're going to do the same process. So we're going to start by, we're going to divide. And looking at this, I can't already just divide like we did in those first couple of problems because I have a 2x minus 5 in the bottom, and that doesn't go into each of the terms up top. So what we're going to do is we're going to set this up. So we're going to have 4x squared minus 4x plus 3. And we're going to divide that by 2x minus 5. So remember, we're always comparing just the first terms. And since I have two terms over on the left, that means I'm going to start up here in the middle. So I'm asking myself, how many times does 2x go into 4x squared? Well, the answer would be 2 times x. So I'm putting it in the middle because I have two terms on the left, or what I'm dividing by. So I do 2x times 2x is going to give me 4x squared. 2x minus 5 is going to give me minus 10. And again, you're subtracting off that entire thing, so I'm putting it in parentheses. So these cancel. I have negative 4 plus 10, so it's going to be 6x. And then I'm comparing the 6x to this 2x. I'm also carrying down this 3. So compare the 2x to 6x. How many times does 2x go into 6x? Well, I would have to multiply it by 3, a positive 3. So 3 times 2x is going to give me 6x. And remember, that should always be the case. So it should always come out to be the number that you're trying to get. That means you're doing it correctly. So 3 times negative 5 is negative 15. Subtracting off in parentheses, these are gone. 3 minus negative 5 is really going to be 3 plus, or 3 minus negative 15 is really 3 plus 15. So I'm going to get 18. So my remainder is 18. So my answer here is going to be 2x plus 3 plus my remainder over what I divided by. So 2x minus 5. All right, let's look at one more. And one thing I want to point out too, when I'm doing these, notice that my polynomials on top are always in standard form, meaning they're always in decreasing order, the exponents. So it goes x to the third, x squared, x, and then the number. If you were missing a term, so let's say this was 50x to the third minus 35x minus 7, you would want to insert like a 0x squared so that you didn't lose that place value. It'll just make your work a little bit easier. So if you're ever missing a term, just make sure you insert it. In this last one, I didn't have an x to the third, but I don't need to put a 0x to the third because it's not going to really matter. It's the fact that if you were missing like an x term, you'd want to put like a 0x in there. So let's look at this last example. And again, we're starting it off the same way. So we have 50 x to the third plus 10x squared minus 35x minus 7. We're dividing that by 5x minus 4. So again, just comparing the first terms here. So I would have to multiply this by a 10x to the second to be able to get 50x to the third. So I'm going to do 10x squared. And notice I put it over the second term because I have two terms in the 5x minus 4. So now I'm going to distribute 10x squared times 5x minus 4. I'm going to get 50x to the third minus 40x squared. Again, you're subtracting those. So it's 10 minus negative 40, which is really going to be 10 plus 40. So it's going to be a 50x squared. Bring down the next term. And then it's going to be looking at the 50x squared with the 5x. So in order to get 5x into 50x squared, you'd have to multiply 5x times 10x, so plus 10x. So I multiply that, I'm going to get 50x squared. 10x times negative 4 is going to be negative 40x. So then I am subtracting using my parentheses. Negative 35 plus 40 is going to be a 5x. You're going to carry down the 7. And then you're comparing these last terms here. So I'm comparing the 5x with the 5x. And you would just multiply 5x by 1 in order to get 5x. So then when I multiply 1 times 5x minus 4, I'm going to be left with 5x minus 4. So I have subtracting this piece. So those are gone. Negative 7 plus 4 is going to be negative 3. So that's your remainder. And so your answer then will be 10x squared plus 10x plus 1 minus your remainder, which is 3. So it's minus 3 because the remainder was negative 3 over what you divided by. So you divided by 5x minus 4 because you didn't have quite the 5x minus 4, so you have a remainder of 3 over 5x minus 4. So really this remainder is being subtracted. Okay, so that's it. We're going to talk about another type of division in the last lesson for this unit.